We should be going live.
Yeah, I'm watching the stream. I'll let you know what's up.
Awesome. So how you doing, Sarah? Good.
Untangling my mind.
Good. Okay. So just to introduce, awesome. Thank you. Just to introduce who we have. I'm Zach. I'm one of the community managers of OneLeaf. I'm joined along with Sabian, another community manager of OneLeaf.
Hello.
And also Sarah, my sister and a moderator for OneLeaf. And this is kind of a continuation of the first stream that I did, the basics or a foundation in Swift, or an intro to the Swift. I forgot what I called it. But this one's going off of that. And you can see to our top left and in the description of the video are our topics for what we're going to be talking about for Swift. And also feel free to ask any questions, and I'll make sure to answer those, or join in the Discord and feel free to jump into our conversation if you want. So the first thing that I'm going to talk about, and I don't know if you're set up, Sarah, to on your Mac or anything like that.
Yeah, I'm good to go.
Okay, cool. So really quick, if you open up the terminal, Sarah, can you? Yep, and just open up the terminal and just cd into documents.
Oh my goodness. Alright.
And so the command that we're going to type in, and feel free to make a directory really quick and go into that, because we're gonna make a Swift package really quick, and we're gonna use the Swift package manager to generate that. So for that to work, we need to be in a package, or I mean a directory that the package will kind of be named at. So I'm gonna make a directory called example project, and I'm gonna go in there, and then once I'm in example project, I can run spm for, oh, whoops. Wait, am I?
Hey, you should definitely, if you can, make your text bigger on your screen.
I'll make it really big. Sorry.
Yep.
So we're gonna use spnm Swift Package Manager. I always mess that up. But the command that we want to use is Swift Package init, and then it's going to be type executable. So can you see that, Sarah?
Yes, it caught up. Yes.
Okay, awesome. So we're going to type this, and once we type this, this will generate all of the files and everything we need for this to be a Swift package project.
Could you ls and show in the folder structure what it creates?
Yep, I'll show that really quick. So we get sources, where we get a main file that says hello world, and then we have tests. And I won't go in the test right now. The really important bit is this package.swift, which kind of says our package name right here. It says any dependencies our package will have, which we don't, and then just kind of our target, which we can run the project. It's an executable, so this is one of our targets, and then another target is tests, and that's just so we can share our dependencies to which one. Don't need to touch on that too much. We'll touch on that later when we actually use some dependencies. So that's the basic structure of that. Now after that, you should be able to type in Swift build. Oops, if I can type right. Oops, sorry. Typing in Swift build in the project will build the whole project. And now that it's built, I can type in Swift run, and it's going to print out hello world for me. So that's just a really quick example of the most basic executable Swift package, and this one's default for you. So if you're on Linux or if you're on Mac, it shouldn't make a difference, since Swift Package Manager works for both. The part that does make a difference is that we're going to actually generate an Xcode project to make it easier to deal with. So we'll type in Swift package generate Xcode project. And when you're typing these in, you can press tab, and if you have like Z shell, which it should be the most updated, or it's the default shell now for the latest version of Mac OS. What terminal am I using? I'm using iTerm 2. I really like it, and yeah, I use it with Z shell. And as I was saying, yeah, Z shell is the default for Mac OS now. But after you run this command, it'll say generated, and all we have to type in now is open, and then whatever that file name is.
Zach, can you also ask if you're going to cover data structures and algorithms with?
Oh, I will cover a little, but not specifically like data structures and showing them as examples. I would love to go into that topic later with examples from a project that I know that has a lot of algorithms and data structures in Swift. And I'll pull that up quick during the stream to show you which one I'm talking about. But I would love to go through that and explain some of them, or to talk about some of that. But I'll pull that up during the stream. I'm trying to find it right now, but I'll multitask and we'll check that out next stream or in some other topic. But if I open up the Swift package, or the Swift project, you can see that I can go into main Swift, and I'll see the hello world right here. And I can change this to say hello YouTube, and now I can even press the run button in Xcode, and it will output to the terminal down here. So we can use Xcode to go through our examples now instead of Playground. The reason I'm not using a Playground is it's because it's a little slower than an actual project, and also I can have separate files in here easier than I can in a Playground. You can still have separate files in a Playground, but they're kind of hidden. So let's make a file really quick, or we'll make a folder. So we'll just go new group, and we'll do optionals. And now I'm just showing the kind of interface of Xcode, how you add files, how you create folders. For right now, simplicity, we're just going to use a Swift file. And it'll automatically make it a Swift one. So to show optionals, I want to talk about the concept of Knoll. Oops, here, let's use a multi-line comment. Knoll, nil. Another one's like undefined, I think, if I spelled that right. Just not show it, whatever. So this is the concept of that there's not a value there. So if I have some value, and it's a string, in Swift, this value, it's gonna, well, it's global, so it'll complain about that. But this value needs an actual value, and maybe this variable value, A, this variable A needs an actual value because it's not optional. And I touched on this a little bit before, but I'm gonna touch on this a little bit more and how you kind of interact with optionals. So if we had B, and it was a string, but it was optional, that means that I don't have to give it a value. And I showed this example of, that means that the string is also nil, or it doesn't have a value. Does that make sense, Sarah? And am I hitting on the point, Sabian, of kind of optionals, or?
To cover a little bit of like under the hood, like when you just have what Zach has here, basically the language Swift, when you run it, says in memory, like this is a process that's running, and in memory I need to have this memory allocated. We don't know what's in there yet. Nothing's in there right now until we say it's not equal to nil.
Yep. So, touching a little bit more on optionals, kind of showing, we'll just put this in a scope. The reason it's complaining about some of this stuff is because it's global. You notice that we're kind of just in open space. So we'll just make a class really quick. That doesn't really matter, but it's just to contain all this code. So now we can have these. and that's fine. So let's say we have a function in this class, and this is meant to be very broad just to give some examples of how to interact with optionals in a sense. And I would love if you have a question on anything like that, then that'd be an even better topic to discuss. But let's say they input their name. So we have user, I guess username, that's weird. But we're going to ask the user for their name. And at this point in code, we don't know what their name is because we haven't asked it. So let's print out what is your name. And at this point, let's say the user actually answers our question and gives us the name Bob. Then at the end, or, well, actually, sorry. Let's change this to a better example of B is username, and we're gonna ask what their name is, and we'll have a function to print out their name. And we'll say like hello Bob, so we'll use the name. And so we're going to do string and interpolation on the username. Boom. All right, so we're saying hello Bob, but we have this warning about what we're doing. And it kind of says a lot of things, but it says something about an optional value, and did we want to make it explicit? So we can provide a default value for this. I'm seeing a question in chat really quick. Is it necessary to provide nil to an optional, and can we leave it empty? Yeah, you can actually leave it empty, and I'm just showing that's the exact same thing. So yeah, feel free to leave it empty. That's mainly what I do. It is redundant to put equals nil. But let's say we want to unwrap the name as unknown user. So in the case that they haven't filled out their name, we'll just say hello unknown user. Okay? So let's check out this class really quick, and we'll use it for an example in our main class. I'm going to bounce around here really quick to the main.swift, and now we'll be able to create this object. And I'm just trying to make this very general because the names and everything that I created doesn't matter other than just showing an example. So for this object, we want to input our name, and then we want to print our name. So in this case, what we should expect is hello Bob. And there we go. So we printed, and then we see hello Bob. Elon Tusk asked if attributes are private by default. I'm pretty sure they're actually public by default. It's weird because I forget because of Swift's module support of how it runs, and I don't want to get into it too much. But pretty much Swift has like namespaces, or what they call modules and package modules that are like internal. So I can put that this class is internal. Oops, if I can type inter. So if some class is internal, that means that I could only use it inside of my package. So I think it's public inside your module, but if you make it for an actual package for a third party or like a framework, or if someone actually uses your package, it needs to be public for them to have access to it. I'm pretty sure that's how it works. But we can look into that more on another stream. I'm always curious about that, but normally I just leave them blank, and I think they're at public. I'm almost positive they are, except for modules. But so if we do this, yes, we see hello Bob. But let's say that we don't ask for their name and we just print out their name. Well, in that case, we're gonna see this unknown user. And Xcode's really nice because I can breakpoint. So Vineeth, if I said that right, we're not actually getting input from the user right now. I'm just mocking it. There's a few ways that you can get input from the user line in Xcode, and nothing happens because I didn't put input name. Here we go. There we go. So now I can put in hello world, and now it'll take in my input. The thing also with readLine is that I don't have to give input, and it gives something weird. So this is the enter character, but that's more of managing strings. Normally you don't use readLine unless for a console application, and you'd use a text field or some UI component for an app or anything. So we'll go with this right now. But first, let's not ask for their name, and let's see how we may use this optional value. Because if I alt-click on it, I can see it's an optional string that I'm using. Let's see how I can make this an actual value that I know the value is always there. So the first way they introduced it in Swift was the default unwrap, 2 question marks, or also you could just put, I'll just copy this because I'm lazy. You could also just put the force unwrap. And so touching a little on what the force unwrap does, it's just gonna blow up my app. It says there's a fatal error, unexpectedly found nil while unwrapping an optional value. So this is kind of the thing of, if you were doing it in Java, you might wrap it in a try catch and catch the error thrown, or maybe you'll do an if check and check if it's nil. For Swift, we have some nice ways, and the first way is an if. So, well, first you can just check if it is nil. And let's say if it is nil, now we're not going to do anything. Yes, there is a char data type in Swift. And really quickly, we can jump into the string. If you command click on anything, you can check out the documentation. And you can kind of see down here. But yeah, there's 2 different ones. There's a C char, which is more of a C actual character. And then there's also just the normal character. But normally you don't use it. Here goes. I think this will still be a string, but if you do the single quotes, then yeah, see, it doesn't really like characters. So if I wanted to access the characters, they got rid of the characters array. So yeah, don't really mess with characters that much, although you do have character support for like you know, that kind tokens or that stuff of like tabs and other things. Those are obviously treated as characters. So if we run this now, going back to what we're doing, we'll see that really nothing happens, and that's because it went into here and it says no name, and because we can check if it's nil. So a better way to do this in Swift is to not check if it's nil, but is to actually use the value. So if I say if let, and I'm saying if let unwraps the name value. So if I put here, I can simply just use name now, and you'll see I have options to both name and username, but name is not optional anymore, and it's also local in scope of these curly braces. So outside of here, I can't use the same stuff. And again, I'm lazy, I'm going to do this. But this will actually give me an error and say this is unresolved identifier of name because it's not in the scope of these blocks. So if I run this, I won't get any output. And if I do this, I'll just get what's your name? I can type in something and it'll give it to me. And I don't have to give it a default value. Okay, so there's one more primary way to get the value, and that's called a guard let. And this is very similar to an if let, but this is more of, if this doesn't pass, if this guard doesn't pass, it's going to return, and you don't have anything else to do. So it's more of everything beyond this point of this guard relies on this value. So you're asking what's the exclamation point after the username? And I'm assuming you're asking about username like this. So username with an exclamation mark means that it's explicitly unwrapped, so, or it's force unwrapped. So that means that the value that I'm using with these two combined is going to be the non-optional value of it, and that's why it crashes, because when this is actually nil or doesn't have a value, it just blows up the app, or it will stop running Swift or the program. Objective-C could run with nils and that stuff, but I'm not going to touch on that too much. Just know that once you try to unwrap a nil and handle a nil, the Swift program will crash. So that's a little touch on optionals right there. Do you have any questions, Sarah or Sabian? Or anyone in chat, obviously? All right. Well, cool. All right, let's just move on then to some exceptions. So I'm going to make another class for this to give another example. And I'll just make a new group. I'll just call it error. Okay, cool. So Swift has errors and try catches. If you've ever used those before in another language, it's just, basic error handling of that. So let's say I have what was before name. I'll hold this up for a little bit longer on the stream, but then I'm going to move on to errors. If you have any questions, feel free to shoot them in chat and I'll answer them. But touching on errors, and I'll switch over now. Let's just make a basic error of, let's just say invalid value or something. Invalid value. And in Swift, all you need to do is make the struct extend from error, and now we just need to give it some error message and maybe something else. So let's say error message and let's just give it a int 2 or something to make it a little bit more unique than just a string. And I guess we don't need to say error because it is an error, so. All right, cool. So we have the struct invalid value, that's an error, and it has a message and a value. So how can we even use this? What does this even mean? Well, let's try the same thing before, as where we take input, but this time we'll throw an error instead of trying to handle optionals. Okay, so we'll have the same class, some value, and I guess we'll just have a var name is an optional string again. Okay. And so for the function, we're going to kind of mock how we did it before. Input name. And we'll say that what is your name? And let's just store the value this time. Let's not assign it to name or anything like that. Let's say that we'll just name it the same as there. And now we want to make sure that this is not optional before we assign it to name. So we'll say that let the input name equals name, and if it doesn't do that, we'll just return. Okay? And then we'll just say, okay, our name is going to be equal to this name. All right. So instead of this, though, we're going to say that this function throws. So this is how you know if a function will throw an error, or if you have to do something special for this function. Because normally you just use functions, just the name of the function, and then parameters or no parameters. But with error handling in Swift, you have to do tries and a do catch and all that, and we'll get into that. But instead of returning, let's throw invalid value, and we'll say, and we'll give it a value of 5. I don't know what that means. Okay, so we got a good question of what's the difference between guard and if else. So I'll write two functions really quick to illustrate the difference. So guard and let's say if else. And let's say I have this bool, and let's say I have this boolean and it's true. Or actually, so yeah, there's just being a little bit more specific. Yeah, the if else. Let's talk about optionals, because this is where it gets a little weird. I guess I could get two examples, but this does diverge a little. So let's talk about this a little bit more, because you can use guards and if else for Boolean logic, or you can use it for optionals. So let's check with Boolean. We can do guard Boolean else return, and we'll try to print, and we'll just say true. And if it goes in here, we'll just say false. And now I'll do an if else. So if Boolean, we'll just print true, and then we can do else print false. Okay. And so now if we do guard and the if else, the guard will be on top for the output. So I'll just type in a name really quick, and we get true and true. So now if I switch the Boolean to false, let me make my screen a little bit bigger. Oops. There you go. So now if I switch the Boolean to false, and after I put in my name, both of them will put false. So this says, a guard says that this must be true, otherwise do this and return. It requires a return. If you use it, you have to return, or you have to throw, or you have to exit the scope. So that's what I was saying right here. This allows me to throw because it's getting out of this function. It's exiting the scope of the function. So I hope that answers the question on guard versus Boolean. But let's say our Boolean was nil, or let's say it maybe was just optional. So if we do guard let, we can unwrap that value, and we can do the same Boolean logic that we did before, where we just say this value. Anything on that, Sabian, or Sarah? Is this making sense?
I got lost a little while back, so now I'm just watching.
Oh, jeez. So yeah, this is the same logic as before. It's just unwrapping this optional, and then it does a comma to use the optional right away. This is an and, the comma, but it's really common in Swift to use the comma instead of the and, especially for listing these logic statements that happen one after the other. So, all right. Well, I won't touch on that for too much longer, because now, since we have an error, going back to this, let's create this object again, and we'll call it some value because that's the one that we're using. And let's say, oops, object. So when we're typing input name out, you can see it says throws. And when we click or we enter this in, we're going to get an error, and it says call can throw but is not marked as try. So you have to have a try if something throws. And even this mainly will get an error in most projects, because when you have a try, you normally need to do catch. If you've ever heard of try catch, that's exactly what this is. And Swift automatically gives us the error passed in, so I can just print out that error. So we'll get rid of this. Actually, that's a little, yeah. You can't really make anything nil, because Swift's type inference, or how it determines the type, nil doesn't have a type, and everything can be nil. So you have to say it is this value. Obviously, I can get rid of this, but you can't do let nil. It just doesn't know what you're talking about. So we'll just try that. And let's run it. Oh, and so now it asks my name, and then it prints out the error with the error message and value. And that's right in here. So if I wanted to print a little bit more on this error, like, uh-oh, then you'll see that come in, of course, too. But I don't have to do catch always, and let's see if this will let me run it. Yeah, see, I thought this would freak out. Error raised at top level. You need to handle it somehow, and normally in a project it won't let you, and it'll ask you to do the do catch. To get around that, you can do a forced try, which is an explicitly unwrapped try. It will force it and not make you use a. Sorry, what am I thinking? It won't make you use a do catch, and you can just have the statement. It'll blow up if it doesn't work, though. So, sorry, this needs to be that. And so now we can see that everything kind of works there. It doesn't print out our name because it's just asking for it, but it takes in this name and doesn't return the error on here. Again, if I change this, we'll see the error and we'll see everything crash because we don't have a value now. The last thing that you can do with the try is a question mark, and that makes the try optional. Which this is one of my favorite parts about error handling in Swift, is that I can just say, if an error pops up or if something's thrown, just return me a nil. Return me an optional value of it. So then I can do if let name, try input name, and now I can print hello name confidently that I know that there is a value. So we're going to run it really quick right now, and it's just going to say, what is your name? Nothing, because it skipped this whole block. So if I had an else, and it says no name, well then it'll print no name because this value is nil. But if I print Leif, oh, that's funny. Bad example. So this function wasn't returning anything. So I would just get a empty tuple, which means void. So if I return name now, then I'll be good. Awesome. So now it prints out my name and says hello, and it'll try to do that. All right? So that's kind of the basics on exceptions and everything like that. Any questions? Anyone in chat? Sabian and Sarah?
Not a follow-on.
Okay, cool. So I'm going to make another folder, of course, and this is just to spread out all the code for if anyone wants to look at it on the GitHub, and I'll share that. And that should be in the description right now. But yeah, feel free to check that out and make any comments on the code and any issues or anything like that. So for this, was this one functions, right? Yeah, functions and closures. All right, so there's, I touched on this a little bit, and I've showed functions right now. Functions are kind of really important to Swift when it's a protocol-oriented programming language. I'll get into that a little bit more, but really having functions, I guess I'm just trying to say, yeah, it's pretty much values and functions to work on those values. Now, the nice thing about Swift is that it's protocol-oriented, so a struct or a class can have a protocol, and those are pretty much the blueprints of what it means to be that protocol. So I guess let's just switch to protocols right now. Just jump to it. So if I have a protocol called Printable, well, let's say that I want anything that's printable to have a method called print self. Okay. And it doesn't return anything. So I think Sabian just answered, but we saw in chat, what's the dash or the arrow mean? That's just the return value of that function. So we'll say return self. I can return self. So that means that I'm returning whatever I am, or I could return a string or give a value back. I won't touch on that right now. So Zach has a quick question of, can Swift scrub internet data like Python can? And I would, yes, it can, but I'm not well versed in how good Python is, and I assume it to be pretty good for scrubbing or anything like that, because there's a lot of people that use it. So I know Swift has the capabilities, yes. I just don't know if it would be as good as Python libraries. I know the performance of Swift might be comparable, but the libraries are really where I'd question Swift's capabilities. But no, I've done it at work. I've done it to grab the App Store web page and scrape the App Store rating and data off of the App Store page for some of the apps that I work on at work. So yeah, Swift can do it. But I'll touch on that more for when I do a URL session talk, or making like a request to some web service or something like that to get weather or anything like that.
I'm going to go ahead and add in a little bit here. I've done a lot of data manipulation in C#. Okay, so I'd highly recommend a statically typed language if you understand how either object or protocol-oriented programming works. because it makes it a lot easier to understand what the data is that you're manipulating. So for example, in Python, if I were to pull some data down and put it into an object, you may not know exactly what type that object is or what all properties that type has. Whereas in Swift or C# or Java, it's much more easy to inspect those types and figure out what's going on inside of them. However, as Zach mentioned, there are a lot of libraries in Python that might make it easier to do what you're trying to do.
Yep. That's a great question. Feel free to message me in Discord, and I'd love to give you examples or talk to you more about it. But going back to the topic of protocols, let's say we have some struct. Maybe, I don't know. I like the pen. The pen class is always a good one. So just modeling after what the basic things of a pen are. Let's say it has ink, and we'll say that's an int. We'll say it has a color, and we'll say that's just a string to make it easy. And let's just say that for right now of just basically a pen's like that. So I'll make an example of a blue pen, and quickly I can just say it has, let's say, 100% ink level, and the color is blue. Alright, so can't do much with the blue pen other than anything inside of this block. But let's say I want that blue pen to be printable. Well, what does that mean? Well, we'll get an error, and that will tell us that we need to have this function inside of our struct. And that means that then we are printable, because we have the function, and you can use print self on anything that is printable because it requires it. So we'll just say the ink left. Actually, let's just do ink %. So I'll do ink and then a %, and I can do that new line character, the /n, and then I can say the color is whatever color it is. So now I can say blue pen dot print self, and this will do that for me. Now I'm going to have to move this into here because this is the main function, and this is what's actually ran. Everything else will have global scope, so I can't actually have just variables in here. But you can see that we have a blue pen, and the ink is 100%, and the color's blue. And it gets the print self from the protocol that it extended from. So if I got rid of this, I could still use it, but you'll see that I could also just have blue pen be printable. And so what does that mean for blue pen at the point of when I'm typing it? Well, the type's not pen anymore, it's printable. So that means that I don't have access, oops, stop typing. I don't have access to the ink color, and I don't have access to the color because this is not a pen anymore, it's a printable. And printable only has print self. So it will still print the correct values, but it's just changed what I can access. So why is that useful? Like, why would I want to downgrade my pen into a printable? Well, let's say I'll just copy this. Let's say we have a pencil. I don't know why I typed pen again. Wood? I don't know, like wood left? Like you gotta shave it down, right? So we'll just inches remaining. Yeah, pretty much. So now we have a pencil. So let's say I create this colored pencil. Yeah, there we go. Red pencil, and this is a pencil that has not much life left, and it's red. Okay. So red pencil is obviously can print self. and blue pen can print self. But let's say I wanted an array of, let's say I have my bag of my pencil bag and my pen bag, and it's just an array of printables. Okay, it's an empty array. Well, I'm going to add my blue pen to it. And here, I'll show the few different examples because I got this question before of what's append. So I can either do a few different examples of adding both of these values to the array, and I can do append. Whoops, I'm not even typing append, thinking red pencil. Or another way that I could do it is the plus equals, and all I need to do is get another array to add to. So both of these will do the exact same thing. I'm just going to keep the little bit cleaner way. Maybe cleaner, I don't know. But yeah, so now the bag will have all my pen. And so if I wanted to go for each of the values, and I'm just using a shorthand really quick that I'll touch on a little bit more later in another topic, but this is just a higher order function using a closure, and I'll touch on that in a second right after this. But for this now, it's going to print all my stuff in my bag, and that's because everything in my bag is printable. So at the minimum, everything is able to print self, or at least it's able to use this function, which I do right here. Are there any questions on that, or does that make sense, Sarah?
Sure.
What doesn't make sense about that?
Mm-hmm.
I might have been messaging people for the meeting that I have in 13 minutes.
No problem.
Sorry.
We get it, you hate us.
Okay.
All right.
Also, gonna have to leave soon for that meeting, so.
No problem.
You.
We only have a few more topics left, so you're not missing too much. So going on to protocols, or going past protocols, Swift has what we call extensions. Oh, okay, so beneath, I'm going to say it wrong every single time. Why did you make the blue pen printable? And it doesn't matter, because I was just showing that a pen is printable. So it doesn't matter. I can still have blue pen as a pen, and it's able to be added to this array.
I think what Zach was trying to show here is that this is similar to a concept in other languages, similar to like interfaces in Java and whatnot, where an object either is something or it has something. Like it either is a subset of a classification or it has a property, right? So in this case, a pen is printable and a pencil is also printable. Or in this case, writable, or whatever you want to name it, right? They both have some property that is in common. In this case, that property that's in common is that they can both call the print self method.
Yep.
Does that make sense?
Yep. And then also asking, what's the difference between blue pen and red pencil without printable? Well, if they're not printable, then they're just separate structs. They are different, so they're not the same, and they'll have different values. You can't have them be the same value, otherwise you'll get an error, redeclaration. But pencil isn't equal to pen just because they have an int and a string, and one string is named the same. Pencil and pen are not related in whatsoever. But the fact when I add printable means that then they're at least printable related, or they are both printable. So I can at least reference them as printable, other than pen or pencil. So Swift has a nice little thing of extension. where I can add a value or I can add a function to some type. That type might be a concrete type like a struct or a class, or it might be a protocol, which is not really an object. It's more of how an object's laid out or the requirements to be a printable or something like that. So the nice part is you can just extend printable, and you can actually do print self in here, so that you just have one thing. Hello, I printed. Well, now the code works. Everything is fine. I don't have to extend, or I don't have to implement print self because there's a default a default implementation. I still have the option to, though, and I can print whatever I want. I could also, well, I guess, let's do, oops, sorry. So what I was showing in the last one is that we could say this print is different, but we don't want a separator, and we want the terminator to just be an empty string instead of a new line. So I could print, and then I could call, so, and one second, I'm trying to make a point here, is that you can't call super because there is no parent. So super refers to object-oriented parent class, and maybe Sabian can explain this a little bit better, but when there's, let's say, oh, instead of drawing this out, oh no, let's we have class A and class B, and B extends from A. So if I say in B, super, whoops, Swift, super refers to A in B. So super, I might be trying to refer to printables declaration, but I can't use that. I can't refer to it if I extend from it.
Zach, as an example for object-oriented programming, I highly recommend using concrete examples. Like, for example, a golden retriever would be a subclass of a dog, and a dog would be a subclass of an animal. That way, it kind of drives the point home that the subclasses are more specific of their parents. But sorry.
Yeah, see, that's a lot different than protocol-oriented programming, because protocol-oriented programming has nothing like that.
Yeah, yours is more about the things that they can do that they have in common.
Yes. So we have the question of, can we add a variable to the protocol? Yes, we can. So let's say that we have a protocol writable. I can't type. And this protocol has some level or level left. Let's just say that. And it has some color, just like the other two. So we're actually going to get an error, and this is because protocols cannot have explicit like variables in them. They're not actual values that I'm using in here. They're supposed to be blueprints or definitions for a class to follow. So I have to do this kind of weird syntax of get and set. So what that means is I can say either one. I can say just get, I can say just set, or I can say both. And that means that I'm able to get the value and I'm able to set the value. Okay? So if we now say, let's get rid of this, we'll get rid of the values on them, and we'll just comma to say it's also something else. So a pencil is printable, but it's also writable. Okay? And now we'll get a little error saying, do we want to add these? And they'll add them for us. Okay? And same thing for pen. Whoops, I messed up. And this one doesn't conform, and then boom. So now they're both printable and writable gives me these variables. And obviously these are different now, so when I'm creating them on the right, I'll just say level left. And now I can change this to writable, and instead of here, I can just print the value dot color. So now I have access to all the variables because I'm referencing the protocol. So that's how you add variables to that. If I wanted to do, let's say, I'm trying to think of an example because just do the dumb thing, description. In Swift we have string descriptions already, so this is kind of a dumb example of you wouldn't really do this, but I'll just add a description and it'll give an error on all of them. But I'm going to do an extension on Writable, and I'll just start typing in description. It doesn't fill it out for me. So description, and this is a string, and since it's only get, I'm just going to return a value, and I'll return color and level left of the percent. So that means that then I can go over here and just type in description, and now when I run it, I'll see blue's at 100% and red's at 25%. So that's showing protocols, protocols with functions, protocols with variables, get set and just get. If it's just get, then you need to have a calculated variable, and that's a variable that only returns a value. You can't set it. So these are nice to just kind of get constructed values off of other things. So these are my classes. I can optionally override functions. But that's the basics of protocol and extensions. Any questions on that before you go, Sarah? No? All right.
Is she gone?
Oh, she already left. I didn't hear her ding out. Okay. Well, are there any questions in the stream chat? I kind of hit all the topics. I haven't really talked too much about classes in Structs, but I touched on those a bit in my last stream. So if there are questions about them, I can talk and show a little bit more examples. But mainly for Structs, you want to use them as like a data type. So if I have, I'm trying to, it's always the examples, like a user, I guess, in my application, the user would most likely be a struct that just kind of says, you know, the variables of them or things I can use on them. A class is more, I'm trying to figure it out for Swift because it's different for all languages. Like Java, you'd always want to use a class because there aren't structs. But for Swift, you're going to want to use a class if you can't use a struct. The ideal of Swift is that you want to first think with protocols and you want to then think with structs. The only reason you don't use a struct is because you need to extend from another class or kind of have reference and not be a data type of kind of value. Now I'm getting into the weeds of it. It's just, yeah, I guess structs are more used for data being destroyed, being less mutated than classes, and classes are meant to kind of contain multiple different structs or classes to either present views or interactions with the user, and that's kind of general. But I'm trying to at least give you an idea of when to use a struct in class. And in Swift, just remember to always think first with, can I use a protocol to help me solve this? And then use a struct. If the Swift tells you or the compiler tells you that you need to start using a class, then, well, I mean, you'll switch to a class, but they're pretty similar, just kind of how they're treated memory-wise, and also with dependencies or protocols. Or protocols are the same, but you can't, a struct can't extend a struct. So I can't have pencil be a pen, that doesn't work. Structs can only extend from protocols, but if this was a class, I still don't think it could extend from pen because it's struct. Maybe it could. No. Oh, that's weird. Yeah, that's what I thought. So then they both need to be classes for this to happen, and the only reason I'm getting them default values is just because I don't want to create an init. Now I'm curious. Oh, well, since it's pen, I don't need to create these again, and it's just going to give me errors on everything now. But yeah, you need classes to extend from each other, so structs can't. All right. Are there any questions? Okay. So you're asking about the program on the right, kind of what's happening on here, or? In the objects. Okay. So I guess we can step through the program line by line. So Xcode has breakpoints, so if you click on any of these numbers, this thing kind of green or whatever theme color you have on will pop up, and you can drag it or you can disable it. But these are breakpoints that when you run them, they'll stop the debugger or they'll stop your program from running and let you print out values or check things out. So we're on the first line, so nothing's been made, so let's step to the next line. So we can press this little button right here. And so now, if I open up this view, we can get a little view of what's going on in our variables. So you can see the bag has 0 values right now. It hasn't really been initialized yet. The blue pen, we can click on it, and we can see the level left and blue. I can also do PO, which is print out, and I can type in a variable to print out kind of the value of it. So we can see that blue pen has been initialized. So if we step again, then now we can see that red pen is initialized, or red pencil, and I can click on here to see, or I can type in PO, and now we can see that. So if I try to print out bag, well, it's not giving me any option to print out bag, and it gives me this weird error, and that's because we're on the line itself. So you just need a step, and now I have access to bag, and it's empty. Okay, so let's see this. Okay, so we're looking, bag is about to have some values in it, and there we go. We see both of the values in bag now, and now we can go inside of here. We're starting the for each, so this is gonna loop a bit. So we're gonna go we're gonna go to some weird stuff. So I'm just gonna break point right here and catch it inside of this block. Obviously I pressed it too late. So if I press here we go. So we're inside of the for each now. So now let's what does the $0 mean? Well, you can just print it out, and it's just the first value in our array. So it's just the blue pen. So we'll print out the description. If we continue, then it'll break point again on here because there's one more value in bag, and we can print out $0 again, and now it's the red one. And so then our program's done. So that's using breakpoints to kind of get a better sense of what's happening in our code and being able to step along and print out values and check that out. So another example really quick of something that you can do with the debugger is if you do E, I should be able to do bag.append red pencil, and now if I do bag, I have the red pencil, and if I step, well, I have the red and blue one. So Swift or Xcode also lets you run E for execute, and it lets you actually execute code that's injected into the program. So I just appended red, even though the code is only appending blue or adding blue. Yes, so Vineeth is asking touching on a great point of, well, that's a lot of protocols and extensions to deal with. Yeah, so you can start seeing that printable and writable. But what do you like? How do you know what pen is? Really, what you want to do is not really use writable like I'm doing. You want to use it where there's shared values, of course. But whenever you're making a struct, normally it has values that are unique to why you're creating it. You don't create structs in classes and then just do this. I guess this would be a bad example because there's always unique values. I guess is cap on in Boolean. Is the pen cap on? Like a pencil doesn't have a pen cap, and that's just an example of, okay, that's not printable and that's not writable. That's something unique to pen. To get around doing this, first off, we'll just kind of ignore the example I have. But the cleaner way to actually do this is to go in and do an extension on the struct, I think. This is like my personal opinion on it. And you can do the values in here. Just the tougher part is, wait, oops, I switched those around. It doesn't have to be specific to what I'm using. But let's say printable and writable are always used together. Well, I mean, I can have what's printable and writable? Usable. Let's just go something dumb. How about that? I don't have really good naming conventions. So I can say that usable is printable and writable. And instead of saying printable and writable all the time, I can just say usable. Now, obviously, this isn't like the best. This doesn't say, hey, this is how you get around it. This adds to the confusion of, okay, usable is now both of these. But this goes on to the exact opposite, and what we're trying to prevent is an object-oriented, very big tree or pyramid of there's one parent class that everything extends from, and coming from menu screen to user profile or whatever, all of them extend from like object or stuff. That's what Objective-C did. Everything extends from NS object. For Swift, we try to break it down and say, here are the protocols of this object. And other than that, it has unique things that it should only know, or values or variables that maybe it should only know. But these are really just to outline, hey, these are usable when multiple things are printable or not. If I didn't have this, if I didn't have any of these, all this is fine. All this code is totally fine. I can have all this just here, but there's no connection between all of them, and also I can't just extend from nothing. But yeah. Going back to the question to make sure I actually answered, or I just rambled enough. Yes, I'm going to say that my answer is not going to answer, yes, it's confusing. It's that you need to be mindful of using them, and you really need to understand why you're using them. And yes, for this example, it doesn't make 100% sense why I'm doing any of this, but it's just an example to show. So I don't like that answer, but maybe, Sabian, do you want to speak on that, anything?
I get what you're going for here. I do think it might be a little murky for the new guys, but them just knowing that these things exist allows them to go out and research and figure out what the right way to do things is. A lot of this stuff is almost just logical, right? Like, for example, going back to the example I did earlier for object giant vat of all the possibilities. You need to figure out what's in that vat before you can pull things out of it and like put them in order on your shelf or something. That was a terrible analogy, but I don't think that's what it does.
Yeah, and it's the balance of protocol-oriented programming versus object-oriented programming. They both have their downfalls, but they both have their goods, and that's inherent with most everything. But a lot of people just look at the extremes of like, okay, object subclass, everything subclasses from object. That's an extreme that I just said, and then using protocols for everything kind of non-needed or unnecessary is another thing. I'm not saying that in Swift I wouldn't do object-oriented. I mean, you could totally still do object-oriented and do the analogy that Sabian was saying with the dog and the, a corgi or, whatever. But with protocols just being so used and so common, but also so powerful in Swift, it's just common to see protocols used quite a bit. So just be wary that there's quite a bit of times that a function may ask for a protocol, and that means that either you need to know of a struct or a class that extends that protocol so you can use it, or extend it on its own. So to give a quick example, error is actually a protocol. And we can see Apple's code, or the Swift code for this, the actual source code, and we see it's a public protocol error. There's an extension with nothing in it for some reason. And then they extend on it and add some more stuff. I won't talk about what that does. Well, maybe I will. It's just saying that whatever type error is, that it can be raw representable, which just means that you can print it out and it has a raw value, and that, yes, the raw value is fixed with integer. And not going to dive into that much because, yeah, you are right. It keeps going. I mean, you can keep diving into the next, okay, so what is that thing? And we load in a bit, and that's a public protocol. That's a binary integer, but it's also this. But the nice part about protocols is once you go to the documentation and you look at fixed with integer, I know its functionality by reading these. I know that it's lossless string convertible. So whatever that means, and we're jumping around a bit, but that means that it has the description property of, yeah, it's that description property that I was talking about, of that, or at least you can do an init from a string. But yeah, it's just kind of a list of what you can use for it. I guess last thing I would touch on is int is the last example, because int is just a struct and it will extend from protocols. So the signed integer and fixed width integer lets me know that it has a fixed width and it's also signed. And then you'll see these static functions for every method that we used, or we may use, the plus equals and what it does, and less than or even equals. And so the equals actually come from comparable, or equatable, sorry. Yes. Alright, will do. I'm just finishing up. See you, man. But yeah, so if I wanted to say that pencil was equatable, well, all I need to do is just say that it's equatable, and if it's basic enough types, or if it's just some variables and there's nothing too fancy and everything is equatable in this, well, then I can do red pencil equals red pencil, which is going to be true. But if I didn't have this, it would give me an error and say that Well, I don't know how to take these two things that you made and tell you if they're equal or not. Equatable is a protocol that will automatically do the equals function if you have the basic types. If I had var other, and let's say other was a pen, well, equatable wouldn't work, and it would make me override this and pretty much just return, okay, left hand side name, or color is equal to the right hand side color. So that's also how you can make the equatable function. So looking at equatable, it's a static function that has a pencil on the left hand side and a pencil on the right hand side, and it will return a Boolean. So you can see we have a pencil on the left hand side and we have a pencil on the right hand side, and we return a Boolean. So last thing really quick, well, what about if we just wanted writable to be equatable? Well, that doesn't work because it's not an actual inherent type. One sec. Yeah, so you'll actually need to put it on something that actually has a value, and that's more of a solid type, like something that we've made that's a struct or a class. But that's an example of why maybe protocols are a nice solution, is because they just add little bits of functionality that are in code and tell us what they do. Are there any more questions? I'm going to check the Discord chat. Alright, looks like we have nothing in the Discord chat for questions, so I'll give you a few minutes to catch up if you have any questions or if you're thinking about anything. Otherwise, I'll end it. Let me try to think if I missed anything that might be a fun little topic to talk about. I guess I'll just talk about closures really quick. I'm not trying to confuse anyone. I'm just trying to elaborate on the topic and lean into the next stream that I have that will more deal with closures. So I'll just show a really quick example, and mind you, it's just an example, so this doesn't, again, mean it, that this is how you should do it or anything like that. This is just to show the difference. The next topics I will cover is actually making a console app, kind of like I'm doing right now, but extending and actually using some of the foundation library from Swift to make a call to maybe get the weather or something like that. So it's going to be actually doing a little bit of a data fetch and getting some data from the internet. And maybe, yeah, we'll check out how to do web scraping and grab a web page and get some data from it. But the last example that I'll show really quick is, and this is how bad I am at naming, I'm just going to say something because it really doesn't matter. I'm just trying to show the different types of these. So we'll have a function called handle. I don't know. And it takes in a value that's a string, and it will return int. Okay. For something, we also have something very similar to handle called handler, which is a variable that takes in a string and returns an int, or is also a closure. So again, this has to have the get set. Awesome. Okay, so we're gonna take this down a little bit more so we can. Oh no! I dropped my drink. Well, we'll just keep going on. I'll ignore it. So we have something And we want our struct A to extend from something. So now we're gonna have to override these two values. Sorry, I'm trying to clean up my mess. So now it'll fill them out for us, and that's always nice. So handle, let's just say handle, we'll just use handler. And we'll just pass the value into here. So just FYI, Swift had an update in 5.2 that automatically returns from one line function. So this is this code right here is technically also returning this. So if I say I have some A, well, I'm going to have to give it a handler, and this is where I define a closure. So if you're using Xcode, you can just press enter on this, and it will kind of fill this out. And so it's going to change quite a bit, but since we're only using a closure in here, we can just go A and then curly braces, and we're going to take in some value. So all we know from this declaration right here is that in this function, we're given a string and we're supposed to give back an int. So value will be a string, and we're going to return 6. But let's print value first. Oops. Okay. All right, so then we can do sum dot handle hello, and again we're gonna have to move this over to here, and now if we run it, it prints out hello, and that's because it's actually hitting this line right here. So what it does is it stores this function or this closure as a variable that I can use later. So if I had this handler function and I just said it was XYZ and I just returned 6, this code that I have right here is equivalent to the code I'm going to write of that I can just say XYZ. And now this is a little weird, but pretty much I can reference this function by just its name. So I could say function to handle. I can't type handle. Everything's looking weird now. I've been staring at the screen for too long. But now I can just say XYZ, and if I alt tab or alt click on this, it will tell me the type that it is a string to int, and that's the same as string to int. So we could, pass in XYZ, or we can pass in function to do things, and we'll have the same thing exactly happen as we did with this code down here. And obviously it doesn't print anything because our function doesn't print anything. So now it does. And you'll see down here now it does print, and that's because it's using this function. So that's the last little bit I wanted to touch on for this stream. I hope you all learned at least one thing. But yeah, feel free to join the Discord and ask me any questions in there, or join the conversation with any of our members in Discord. It's always open. I'll be continuing the stream next week, talking a little bit more about using or calling from an API and actually making some web or some URL requests with Swift. So we'll try to get the weather, and we'll fetch a website and pull some data from it. And also, of course, I'll answer any questions that people may have, either in the Discord or comments on the YouTube video. So last thing, is there any other questions before I sign off? Thank you all for watching. Make sure to like and subscribe, and join us in Discord. We really want to connect with you and join your project, hear about your project, but also have you come work on some of our projects and join the community and really kind of work together. So if there isn't any questions, I can stop rambling and sign off. Again, like I just said, thank you all for watching. Join the One Leaf Discord. Check out the One Leaf website. I will show it really quick right here. This will probably be the first public appearance, but we did get the dev website up. Now this is still under construction, so we have the One Leaf website, which is very outdated on where we're at, and this is more of where we're actually at for development. So we have contact us, active projects, meet the team, and this will kind of be the outline, or this is most of the designs or outline for the website. We're filling in all the assets and kind of the copy or the text. So feel free to check that out. That's the One Leaf website project. So, all right. Oh, I haven't done it in a while. And when I did, I used Java. So I would say if I ever did competitive programming, I would want to use Swift, and I would think it'd be very good. But it all depends on the problems. Some languages have better support for some tasks, and some languages just have better libraries that support the problems that they need to solve. So I would say it's good, but it's more limiting. I mean, you can make a website with it, but you could also just make a website with JavaScript or Python or all these other languages that seem to be a little bit more popular for hackathons. I hope that answers it. But yeah, I personally would love it as a competitive competitive programming, but it's not like many people use it. All right, awesome. Well, I think that's all. Or maybe if you have another question beneath. And I'll wait till 8 or 7:30 until I hang up the stream for anyone else, just because I don't want to close it off if you have any questions. So it's coming up the end. I'm going to end it, but really quick. Here's the Swift Algorithm Club. It's by Ray Wenderlich. Really recommend Ray Wenderlich's topics, but this has tons of data structures, tons of algorithms, all in Swift. So I will definitely make sure to go over some of these or to show some examples of that. So that's what I would definitely recommend for checking out data sources and algorithms. But other than that, thank you guys so much for watching. I'll see you in the next stream. See you next week. And make sure to check out Sabian's stream tomorrow for C# at 6 o'clock Central Time. And also on Thursday, the One Leaf stream at 7 p.m. Central Time. All right. See you guys.